Okay, so we're trying to find sine, cosine, and tangent for a right triangle where we have all the sides. Now, if you don't have all three sides to the right triangle, or you're missing one that you need based on like what you're asked, you can use the Pythagorean theorem. So remember, Pythagorean says a squared plus b squared equals c squared, where c is the hypotenuse and a and b are legs. So the legs are the portion that are touching the right angle. So those would be the legs, A and B. And then the hypotenuse is the side away from the right angle. So not touching it, that's your C. Okay, now again, these two already have all the sizes, so we don't have to do that, but we might have to do it later. So now we're going to make a definition. We're going to define the sine of an angle is equal to the opposite side over the hypotenuse. The cosine of an angle is the adjacent side over the hypotenuse. And the tangent of an angle is opposite over adjacent. So some guy realized that when you have triangles that have the same angles, their ratio of sides are the same. So we're going to define the ratio of the opposite side to the hypotenuse as sine, and the ratio of adjacent side to the hypotenuse as cosine, and the ratio of opposite over adjacent as tangent. So now this question is asking for tangent of L. So L is the angle I'm looking for. Or looking at. So all the way across the part that the leg that is not touching L, that's called the opposite side. And the hypotenuse is always still the side that is across from the right angle. So now you'll see this angle L is made with those two rays or line segments. And so one of them was named hypotenuse. So the one that's touching L, that's not the hypotenuse, is called the adjacent side. So if I want the tangent of L, that's going to be opposite over adjacent. So the side opposite is 3. And the side which is adjacent is 4. So the tangent of L is 3/4. Let's try sine of L. So sine of L is going to be opposite over hypotenuse. So the opposite side is 3, and the hypotenuse is 5. So the sine of L is 3/5. And then last, let's do the cosine of L. So cosine is adjacent over hypotenuse. So the adjacent side is 4, and the hypotenuse side is 5. So the cosine of the angle L is 4/5. Okay, so now let's try it again. In this one, again, they give you all the sides, so we don't have to find anything right now. And the angle that we're looking at is angle L. So see, they're calling the angle L. So here's the angle L. So I encourage you to pause the video and see if you can label opposite side, adjacent side, and hypotenuse. So L opens up to 8. So 8 is the opposite side. Now, hypotenuse is always opposite the right angle. So 17 is the hypotenuse. And then L is made of two line segments. One of them was the hypotenuse. The other one is the adjacent side. So now, while you're learning, you may need to write the rule every time you use it. So tangent is opposite over adjacent. That's its definition. So 8/15. right? Opposite is 8, 15 is adjacent. Okay, now let's do sine of L. So sine is opposite over hypotenuse. So from L, opposite is 8, and the hypotenuse is 17. So the sine of L is 8 over 17. Okay, cosine of L. So cosine is defined as adjacent over hypotenuse. So adjacent is 15 and hypotenuse is 17. So cosine of L, which again is just a definition of the ratio of sides in a triangle where the top number is the adjacent side and the bottom number is the hypotenuse side. So you have a triangle that has L as its angle. So now we're finished with this problem, but I just want to remind you that, you could have a triangle. This is a pretty bad drawing, but you could have a triangle that was, a dilation of this triangle, meaning I just made it bigger, and it would keep the same ratios. So this angle, which we'll just call L prime for a second, will have the same measure as the original L angle. And we know from similar triangles that the ratio of sides has a constant proportion. So like, let's say that my pink triangle is double my original triangle. Then the hypotenuse would be 34, the adjacent would be 30, and the opposite would be 16. And you'll notice, we'll just do cosine because I've written everything in pink here. So if I take adjacent over hypotenuse, the adjacent side for L prime is 30 and the hypotenuse side is 34, and those are both divisible by 2. So when I simplify my fraction, I get 15 over 17, which is the same as the cosine of the original L. So this is technically cosine of L prime. But again, if you just make a bigger triangle with the same 3 angles, they're similar, and similar means they're proportionate. So whatever, multiple you do to one side, you have to multiply all the sides by that same number. So when you take their ratio, that number divides out of both, and you get the same exact ratio as the smaller triangle. So now let's talk about special triangles. So there's 2 special triangles, the 60, 30, 90 triangle and the 45, 45, 90 triangle. So let's just talk about those real quick. Let's start with 45, 45, 90. So in this picture, I'm going to say that this guy is definitely 45 degrees. So I'm defining the measurement of that opening. This guy also has to be 45 degrees. Now, why is that? Because the sum of angles in a triangle is 180. We already accounted for 90 in the corner. So we wanted one of them to be 45, which means the other one has to be 45. But now the thing about that is that in a triangle that has 45 degrees and 45 degrees and of course 90, that the opposite of each of those 45 degrees will be the same value, because if you're opening this much and this side is this long, then when you open, you get another side which is that long. But the same would have to be true for this 45-degree angle. So these 2 sides are going to match. Like if one is called X, the other is called X. So what I'm going to do is I'm going to call these 1 and 1 for just a second. Now, because this is a right triangle, remember what I said at the beginning, that you can't if you are missing one of the sides, you can use Pythagorean theorem. So you could do 1 squared plus 1 squared equals c squared, or the hypotenuse squared. So c squared equals 2, and c is the square root of 2. So what that tells me is that the sine of 45 degrees, so pick one of your 45s, opposite is 1, adjacent is 1, and hypotenuse is square root of 2. So the sine of 45 degrees is opposite over hypotenuse. So 1 over the square root of 2. And if we wanted to rationalize that, we could times the top and bottom by square root of 2, because square root of 2 times square root of 2 is just 2. So we get this rule that the sine of 45 degrees is the square root of 2 over 2. So now cosine of 45 degrees is going to be adjacent over hypotenuse, which again, the opposite and the adjacent sides are the same length. So 1 over square root of 2, which is the same as square root of 2 over 2. Depending on the custom, we generally don't leave a radical in the bottom, but sometimes like we don't actually care that there's a radical in the bottom, and you could leave it as 1 over square root of 2. And then finally, tangent of 45 degrees. Well, tangent is opposite over adjacent. So the opposite was 1 and the adjacent was 1. So the tangent of all triangles that have 45 degrees, the tangent of every 45 degrees will be 1, meaning the opposite side is the same as the adjacent side. So now let's talk about in general. So in a 45, 90, 45 triangle, if I call the sides that match x, then what would the hypotenuse be? Like, how would I find the hypotenuse? And it's the same way that we found it before. We would take one side squared plus the other side squared is equal to c squared. But now x squared plus x squared, that's 2x squared, c, and that's equal to c squared. So if I want to kill the square, I have to square root, and the square root of c squared is just c. But now here, I have to do both the square root of 2 and the square root of x squared. Now, because these are triangles, we're taking this as the positive or primary square root of x squared, which is just x. But the square root of 2 still stays the square root of 2. Now, the x is no longer in there, so I'm going to say x times the square root of 2. So, in every 45-degree right triangle, if you know one of the legs, you can get the other leg because it's the same, and you can get the hypotenuse by taking that length and multiplying by the square root of 2. So then if you know the hypotenuse length, you can get the leg length by dividing by the square root of 2. So in this 45-45 triangle, we know the hypotenuse. So we know c is equal to 6. So c is equal to 6, but in our setup, c is also equal to x times the square root of 2. So now, if we want to get x alone, we're going to divide by the square root of 2. And that gives me x equals 6 over square root 2. So now if we rationalize square root 2 over square root 2, on top I have 6 rad 2, and on bottom I've got 2. And this cancels, and you get 3 rad 2 as your x length. And in our setup, x was the leg. So this side will be 3 square root 2, and this side will also be 3 square root 2. So I found the value of D. Okay, let's try another one. And I encourage you to pause it and try it and then see if you get it right. So here our C value is 5, and that is x times the square root of 2. So to get x alone, we're going to divide by the square root of 2. So I get 5 over square root of 2 equals x. And if I rationalize that, I get x equals 5 rad 2 over 2. So now what did x represent? It represented the two legs of your 45-45 triangle with a hypotenuse of 5. So each leg would be 5 rad 2 over 2, 5 rad 2 over 2. Okay, let's talk about 30, 60, 90. So we're going to actually try to do something a little bit creative here in how we construct our 30, 60, 90 triangle. So in 45, 45, 45, we constructed the triangle, but we knew the two sides, the two legs, had to be the same exact value. So we're like, let's just pick the easiest value, 1, and then we'll figure out the hypotenuse and we can find all the ratios. But the problem is if we have a 30, 60, 90 triangle, so 60, 30, and a right angle, which of those sides am I calling 1? And then how do I get the other ones? Like once I know the ratio of sides for 30 or the ratio of sides for 60, I can figure that out. But in order to get those ratios, we have to have a triangle we can work with. So instead of working with a straight 90-degree triangle here, what I'm going to do is I'm going to draw an equilateral triangle. Now, equilateral means all of these are the same size and all of these angles are the same size. So those guys are all 60 degrees because we know there's 180 degrees in a triangle and all three angles are the same, so each one is 60. But now, before I do this with x values, I'm going to put a value on. Excuse me. So I'm going to say that each side is size 1 because that's the most logical choice. But now you should be thinking, hey, we didn't define sine, cosine, tangent based on an equilateral triangle. We decided it based on a right triangle. So what I'm going to do to create a right triangle, and this is where the brilliance is I'm going to drop a perpendicular. So now, since this is an equilateral triangle, this perpendicular has cut the angle in two. So the whole entire thing was 60, but when I cut it in two, it becomes 30. But now again, because of rules of geometry and the fact that this is an equilateral triangle, when you drop the perpendicular, you also break the leg in half. So you broke the angle in half, and then you're going to break the side of the triangle in half. So this side here will be 1/2. And now I'm just going to extract this triangle. Where this was 1, this was 30, this was 60, and this was 1/2. Now, if you are good at math and you like fractions, you can go from here, right? You can have one leg that we don't know, square, square, add together, and that has to equal the hypotenuse squared. But most people are like, ugh, 1/2. So remember that, the ratio of the sides is the same, no matter the size of the triangle, as long as the angles, all three angles are the same. So as long as the triangles are similar. So what I'm going to do to kill this fraction is I'm going to make this triangle 2 times bigger. So I'm going to draw it like this in green for effect. This is still 60 degrees. This is still 90, and this is still 30, because I'm just making this twice as big. So the hypotenuse would be size 2, and this bottom leg on the bottom is going to be size 1. And this makes this a lot easier to work with than having a radical, or having a fraction. Okay, so now in order to define sine, cosine, tangent for 30 and sine, cosine, tangent for 60, I need the other side of the triangle. So to find this side of the triangle, this blue side, I'm going to call it x for right now. So I have x squared plus 1 squared equals 2 squared. So x squared plus 1 equals 4. X squared equals 3. And because we're dealing with actual triangles with actual sides, we're going to take the primary square root and we're going to say positive square root of 3. So now here, that side will be the square root of 3, and we can do our calculations. So let's first look at 30 degrees. So if we're looking at 30 degrees, opposite is 1, adjacent is square root of 3, and hypotenuse is 2. So if I wanted the sine of 30 degrees, I would do opposite 1 over hypotenuse 2. And then cosine of 30 degrees. So cosine is adjacent over hypotenuse. So adjacent is the square root of 3, and then hypotenuse is 2. So the sine of 30 is 1/2. The cosine of 30 degrees is square root of 3 over 2. And now if I want to do tangent of 30 degrees, it will be opposite over adjacent. So 1 over the square root of 3, which if we rationalize that, so we're multiplying by the square root of 3 on top and bottom, we get square root of 3, and then big divides 3, because those two square roots of 3 cancel into just 3. Okay, so now if I want to label these with x's, well, before I label them with x's, let's do 60 degrees. 60 degrees. So let me get another color. Let's do orange. Okay, so we're going to make 60 degrees the angle that we're looking at now. So if we go across, this will be the opposite. And then 1 will be the adjacent, and 2 will still be the hypotenuse. So the sine of 60 degrees is opposite square root of 3 over hypotenuse 2. And then cosine of 60 degrees would be adjacent. So remember, we're looking at the orange words now. Adjacent is 1 and hypotenuse is 2. And then tangent of 60 degrees is going to be opposite over adjacent. So square root of 3 over 1, which is just the square root of 3. And if you're thinking, hey, those kind of look related, well, they are because they're from the same triangle. Now let's talk about it in general. So if I call this side x, then the hypotenuse here, I'm highlighting it in yellow, the hypotenuse would have to be twice that. So the hypotenuse will be 2x. And now let's think about how we got square root of 3. We got the square root of 3 by taking x. Oh, I should not have used x. Oh, I'm going to call this y over here. All right, so if I called the one side or the one leg x, then I would have x squared plus, now remember, this blue side, I don't know it. I want it in terms of x. So I will call it b squared equals c squared. So 2x squared. Now here, I'm solving for b. So x squared plus b squared equals, now when you square 2x, you're timesing 2x by 2x, which makes 4x squared. And so now if I subtract x squared from both sides, I get b squared equals 3x squared. So now if I take the square root to get rid of the square, I'm going to use the primary square root. And I get b equals, the square root of 3 is just the square root of 3, and the square root of x squared is x. So this guy here is x times the square root of 3. So every 30, 60, 90 triangle will have this setup. The short leg will be called x, the hypotenuse is 2x, and the long leg will be x times the square root of 3. So now let's apply that to a problem. So here, the short side, or the side that 30 opens up to, is x. The hypotenuse is 2x, and the long leg is x times the square root of 3. So now from this problem, what do I know? I know that 2x has to equal 3, so x is 3 over 2. So now this side will be 2 times 3 over 2, right, 2x. This guy will just be 3 over 2. And then this guy, the a side, x times the square root of 3 will be 3 over 2 square root of 3. So what is a? A is 3 square root 3 over 2. Okay, so I got one more to try over here. So pause the video, give it a try, come back. Okay, so we're going to call the short leg x, the hypotenuse 2x, and the long side x times the square root of 2. So if I look at my picture, I know that x is equal to 2, which means the hypotenuse will be 2 times 2, which is 4. And the long side will be 2 square root of 2. So which one did we want? We wanted the h for hypotenuse, so the h was